For matriculation syllabus, we will not be discussing plane mirrors. So those are in SPM. But the concept that we learned, the law of reflection will be greatly applied. In this case, when we are talking about mirrors, we'll be using law of reflection. Okay, so mirrors are a surface where you can approximate that it's fully, any light that hits the mirror will be fully reflected. Okay, there's no refraction that occurs for a perfect mirrors. Okay, so in our case here, we'll be studying a kind of mirror, a curved mirror, which we call a spherical mirrors. So what is a spherical mirrors? You can think of it like this. So let's say you have a 3D sphere. So you can think of it as ball. Now if you cut out a portion of the surface of that sphere, and that surface here, that curved surface, will be called the spherical mirrors. Okay, so I have shaded this part of the surface on the right hand side of the surface only because I want to indicate that this part is opaque. So light can come from here, but it will not get through to the other side. It will have to be reflected. It will be completely reflected. There's no transmission, there's no refraction. Okay, so a few things that we usually label when you have a mirrors is we first have to draw an optic axis. Okay, this is called an optic axis, which is the axis that splits the mirror into two. Okay, and on that optic axis, we will label a few things. The first thing is called the center of curvature. The center of curvature is basically just the center of the 3D sphere that construct this mirror. Okay, so any point on the spherical mirror surface, if you find the distance of that point towards this center of curvature, you'll find that the distance will be the radius of curvature. Any point on the mirror, if you find the distance of it from the center of curvature, you'll find it to be the radius of curvature, which is equals to r, which is actually the radius of the 3D sphere. Okay, so now if you place an object over here, in this case a cute teddy or bat, I'm not sure. Okay, you put some kind of stuff over here, then the object, we will call this thing here to be an object. Okay, and the distance of that object from the vertex of this mirror. Vertex of the mirror is the intersection between the optic axis and the mirror. So this intersection, we call it the vertex, and the distance of the object from the vertex, we call it the object distance, which we call it as u. Okay, and the object here, we will label it with its height, and we call the object height as ho, h subscript o representing object. Okay, so in this case, the object is here, so this mirror here should be called a concave spherical mirrors, because the center of curvature is in front of the mirror. Okay, so this is the idea of a spherical mirrors. So we will now move forward to study how light travels when it comes to this kind of mirrors. So you have learned this in SPM before. You usually draw some kind of light rays coming from an object, usually represented with an upper arrow, right? An object. Then you have rays coming off the object, then you get reflected off the curved mirror surface here. But if I draw light coming out from the teddy bear, does that mean that the teddy bear is actually producing light? Is it like a glowing teddy bear or what? Well, the idea is it's not always the case. It can be the case, but it's not always the case. Okay, so right here, you can have light rays actually reflecting off the teddy bear, just like this. You can have light rays coming from other sources, let's say your light bulb, and you get reflected off to other directions. Okay, light comes from many different sources, let's say your sun, your light bulb, or it can be reflected off the wall towards the teddy bear. But many of them will get reflected off to various angles. Some will not even hit the mirrors, right? All these here will not even hit the mirrors. But if you notice here, there are some rays which will be incidenting on the mirror. And those are the rays that we will be considering when we are studying how light propagates and how light interacts when it encounters a mirror. Okay, so when light is coming towards the mirror, we call these kind of rays incoming rays or incident rays. Okay, when it already reached the mirror and it gets reflected off, those kind of rays we call it outgoing rays, or we call it reflected rays. Okay, so yeah, so that's the idea for incoming ray. And now let's move on to study how it gets reflected off the mirror. Well, we usually focus on one point on the object when we are discussing how the light rays goes off from the object and form an image after that. Okay, we usually focus on one single point because if you want to focus on many points, it's okay. But you make the ray diagram extremely complicated that you cannot really trace a line really well. Even now, you see I start everything from one point and you can see that the ray diagram is actually fairly complicated already. So that's why we choose to focus on one point. And let's say if you want to deduce another point, you can just change your object point over here, then you deduce the image point is where. And from there you can deduce the whole teddy bear. How will the image be? Okay, so there are many lines over here, and actually the angles for this line here is not really easy to determine. Most of the rays have reflection that is quite troublesome to determine their direction. Let's say this light green line over here. How do I know that it's reflected towards this point over here? Well, I need to do some geometry in order for me to know that it's getting reflected this way. For example, what I did is I did something like this over here. I draw a dotted line towards this point over here where it interacts with the mirror. So this dotted line represents the normal. And you learn from your maths that any radial lines from the center to any point on the circle, then that line will be normal to the spherical surface. Okay, that's what you learn, I think, in what do you call it? In your form 3, yeah, you learn that tangent line, normal line, yeah. So using your normal line, you know that any rays that comes in will come in at an angle of incidence, and what you need to make sure is your angle of reflection will be equal to the angle of incidence. And from there, I deduce that my line will be going this way. Okay, you can see that the normal line is in between this incident ray and the reflected ray. Okay, it's pretty troublesome actually if you want to determine everything using this method, one by one. Okay, and the thing is, it's troublesome and it's not really necessary to do so, because if you see here, all of the rays here actually intersect at one single point. So if you are able to find just any two lines, you are able to find what's the intersection between that two rays, it's enough really, right? Because all of them will eventually intersect at the same point. So therefore, we only need to know two, and there's actually three lines that is easy to draw. Okay, there are three specific directions of incidence ray where the reflection can be easily determined. So now we'll be studying that three specific directions of incident rays where we can use to draw our ray diagram.